Good morning, everyone. I welcome you all in this one short video. So, we will discuss the unit third, the main topics that are important for your examination point of view. So, first of all, I want to let you know that in your answer, Mr. Test EST, you have almost the 26 marks from your third unit. That's the differential equation. What's the syllabus in it? That is, first, you have the introduction of differential equation, in which you first define the what is differential equation, then what is the order of a differential equation, what's the degree of the differential equation, what is linear differential equation, what is non-linear differential equation, and you can go through the previous video, that's the video 1 and 2. So that will be, I think, as a 2 marks question in your examination. They may ask you the order, they may ask you the definition of order, definition of degree. They may give some question there and ask you what is the order of the differential equation. Then similarly, the second topic is the exact differential equation. In that, you have to find the solution of the exact differential equation. Here the chances is for the 2 marks as well as the 5 marks. So in the 2 marks, they will give you one differential equation and may ask you whether it is exact or not. Or they may give you one differential equation and they will ask you that what is the integrating factor for this differential equation and to make it as exact. Or they may ask you the definition of the exact differential equation, necessary and sufficient condition. And it may be the 5 marks why they will give the differential equation and you have to find the solution, or you have to reduce it into the exact differential equation. So in the exact differential equation you have to find the solution. Otherwise, if it is not the exact, then you have to make it the exact by the integrating factor. So there may be the chances they will ask you the definition of the integrating factor and they will give you the differential equation and ask you what is the integrating factor for this. Okay. Similarly, another one is the Leibniz differential equation and Bernoulli's differential equation. So this question may be of the 5 marks. They will give one differential equation and ask you to find the solution of this differential equation. They will not tell you that what type of differential equation it is. वो नहीं कहेंगे कि ये कौन सी differential equation है. आपको खुद देखना है कि अगर ये Leibniz है तो इसका solution किस तरीके से ढूंढते हैं, और अगर ये Bernoulli's है तो इसका solution कैसे ढूंढते हैं. Now moving to the another topic of, that is the second part of your unit third, that is the linear differential equation with constant coefficients. So in that they will give any type of the differential equation and you have to find a solution. So you have to find the complementary function for the higher order function and you have to find the particular integral for the functions, whether exponential, whether sine, whether cos, whether the product of the exponential and the another cases. Okay, so that is the polynomial or the sine and cos. Okay, so this is all about the syllabus. Even here the 10 marks, this is for the 10 marks, and for the 5 marks they will give you some equation and tell you that what is the complementary function, so you have to do it in that way. Okay, so now here you have the Cauchy and the Legendry's differential equation, and that may be of the 10 marks as well. So for the definitions and all, you just go to the last videos. We will just practice some questions here. So for example, in the differential equation, they will give you one differential equation, dy by d of x is equal to x plus sine x. or they will give you the d cube y by dx cube plus dy by d of x plus y is equal to 0. So here they may ask you what is the degree, what is the order. So here the order is 1, the degree is 1. So here the order is 3 and the degree is 1. Okay. So these type of the questions will be in the order and degree, and they may ask you the definition as well. So at the order of the different, they may ask you even the whether it is the ordinary differential equation or it is a partial differential equation on the basis of the independent variable. So when we have the single independent variable, we will say that it is the ordinary differential equation, and if it has the more than one independent variable, we say it is the partial differential equation. Okay. So similarly, the order of a differential equation is order of the highest order derivative in the differential equation. Okay. And the degree of the differential equation is the degree of the highest derivative when differential coefficients are made free from fractions and the radicals. For example, they will give you the d cube y by dx cube is equal to dy by d of x ka whole square plus 1, and you can see that the order is here, that is the 3, and the degree is also 1. And here d cube y by dx cube is equal to root of dy by d of x plus 1. So you can see the order is here 3, and the degree we can't say until we will just make it free from the radical. So we will square it both sides, so we will have d cube y by dx cube whole square is equal to dy by d of x plus 1. So now the degree is 2. So these type of questions will be there in the 2 marks questions. Or sometimes the degree, they will give the differential equation in which we have the log of dy by d of x, or e raised to power dy by d of x, or the sine of dy by d of x, cos of dy by d of x, and the degree for these type of the differential equations does not exist. Okay. So now when we say that a differential equation is linear, they may ask you what is a linear differential equation. So you have to say that a differential equation is linear. The first condition is that every dependent variable and its derivatives occurs in first order. Okay, sorry, first degree, not first order. So now, second, there should be no product of dependent variable and its derivative. Okay. So they may give you the differential equation and they ask you whether it is the linear or not. For example, dy by d of x is equal to x plus sine of x. So you can check that your this one is linear because your dependent variable and its derivative are of the first degree. So similarly, d square y by dx square plus x dy by d of x plus y is equal to sine of x. So it is also linear. Okay. So for example, you have y dy by d of x plus sine of x is equal to 0. It is non-linear because you have the product of the dependent variable and it is derivative. So they may give the questions like this. So then they will ask you what is the solution of a differential equation. We have discussed it, the particular solution, the singular solution, the general solution. So the question then after that is the most expected question, that is from the exact differential equations. So what is an exact differential equation? We say that a differential equation obtaining from its primitive directly by the differentiation without any operation of multiplication, elimination or reduction is said to be an exact. And what is the necessary, and this is very important, what is the necessary and sufficient condition for a differential equation, that is, this is a necessary and sufficient condition for the differential equation that is in the form of m dx plus n dy is equal to 0. What is the necessary condition that this should be exact? Okay, this is exact. So that necessary and sufficient condition, we know that dou m by dou of x should be equal to dou n by dou of x. If this is true, if dou m by dou of x is equal to dou n by dou of y, so if this is true, okay, then we see that it is exact. What does it mean? So this means that we are differentiating the coefficient of dx with respect to the x only, and with the coefficient of n with respect to the y only. Then what is the solution? So the solution of, then if a differential equation is exact, then the solution will be the integral of m dx plus integral of n dy is equal to c. So what is here? Here we are considering y is constant, and here we are only considering those terms that are free from x. Okay, only the terms that are free from x we are considering and integrating it. Okay, so they may give the differential equation, and they will not ask you that you have to just find the solution of this by this method. No, you have to check with which method you will find the solution. If it is in this form, try to find the solution in by the exact differential equation form. That means if it is not the exact, then find the integrating factor and all. Please go through my videos, you will get what is the integrating factor and how we are solving it. Okay, now we will solve some of the questions that are important for your examination point of view. For example, they may ask you the question that solve the differential equation dy by d of x is equal to 1 plus x plus 1 minus x. So first you have to check with which type you can make it. So what will you do? So you will write it dy by d of x is equal to 1 plus x plus 1 minus y. So you can make it in this form: dy upon d of x is equal to, or take this minus y on the LHS, so it will be plus y is equal to 2 plus x. Now you can check that it is in the form of dy upon d of x plus p of x of y is equal to q of x. So what is this? This is the linear differential equation that you call as a Leibniz differential equation. So what is the p of x here? That is as 1, and what is the q of x? That is equal to 2 plus x. And how you are solving the Leibniz linear differential equation? So you are solving the Leibniz differential equation that y into integrating factor, it is a solution, isn't it? So is equal to integral of q into integrating factor dx plus c. What is the integrating factor? So integrating factor is e raised to the power integral of p of x dx. So now what is here? P of x, that is 1, and 1 into d of x, so that is e raised to the power x. Now put it here. So your solution will be y into e raised to the power x is equal to integral of 2 plus x e raised to the power x dx plus c. So it is integral of 2 e raised to the power x plus integral of x e raised to the power x dx, here dx as well, plus c. So here it will be 2 e raised to the power x plus, here it is by the parts, x e raised to the power x minus integral of e raised to the power x, that is e raised to the power x plus c. So now it will be equal to e raised to the power x plus x e raised to the power x plus c. So y times e raised to the power x. So just cancel the e raised to the power x on the both sides. You will get y is equal to 1 plus x plus c e raised to the power minus x. This is the solution. Okay. So similarly, they may ask the question in this way: the dy upon d of x plus y by x is equal to e raised to the power x. Okay, so what will you do? Similarly, here compare it with the dy upon d of x plus p of x of y is equal to q of x. So now here in this case your p is equal to 1 by x and your q of x is equal to e raised to power x. So now it is the Leibniz linear differential equation. You have to find the integrating factor, that is e integral of 1 by x dx, that is p of x is 1 by x. So ये किसके बराबर निकलेगा, e raised to power log of x, so that is x and log will go, so it is x. So what is the solution? Y times x is equal to integral of q of x is e raised to power x into x dx plus c. Okay, so that is integral of x e raised to power x plus c dx plus c. So this is integration by parts, so it will be x e raised to power x minus integral of e raised to power x plus c. So it will be x e raised to power x minus e raised to power x plus c. So here it is y times x, isn't it? Y times x. So now what is the solution here? For this one, the solution is y is equal to e raised to power x common, so that is 1 minus, and x, take this x on the RHS, it will be x by x, that's 1 minus 1 by x plus c by x. This is the solution. Okay, similarly they may ask you the same type of the question in this Leibniz linear differential equation in this way, that is if they will give the question dy upon d of x plus 1 plus 1 by x y is equal to 1 by x. So compare this type of linear equation with this dy by d of x plus p of x y is equal to q of x. That's a Leibniz linear differential equation. So what is here p of x? So you know that is 1 plus 1 by x, and what is q of x here? That is 1 upon x. So what is the integrating factor? That is e integral of p of x dx. So that is e integral of 1 plus 1 by x dx, isn't it? So what will you do? So that is equal to e raised to power integral of dx, that is x plus log of x. Okay, so that is e raised to power x into e raised to power log of x. So e and log will go, so x e raised to power x is the integrating factor. Then what is the solution? What is the solution? So that is y x e raised to power x is equal to q of x, that's 1 by x times x e raised to power x dx plus c, and x will go. Okay, so it is integral e raised to power x dx plus c. So you will get y e raised to power x will be e raised to power x plus c. So y will be equal to, take this part on the RHS, so e raised to power x, e raised to power x will go, so it is 1 by x plus c e raised to power minus x divided by x, and this is the solution of this Leibniz linear differential equation. Okay, even you can write it in this way, 1 plus c e raised to power minus x divided by x. Okay, so of the same type means the Leibniz linear differential equation, there may be the question in this way. For example, the question will be x log of x dy upon d of x plus y is equal to 2 log of x. But you know that you have the dy upon d of x plus p of x of y is equal to q of x. The coefficient of dy by d of x should be 1. So here it is log x log of x. So what will you do? You have to make it 1. So for that you will divide it wholly. Okay, so you will divide this x log of x throughout this. So you will get dy upon d of x plus 1 by x log of x y is equal to 2 log of x divided by x log of x. So it will be dy upon d of x plus 1 by x log of x y is equal to 2 by x. So now your p is 1 by x log of x and your q is equal to 2 by x. So for this now your solution So first you have to find the integrating factor, that is e integral of p of d of x. Your p is 1 by x log of x, is it, dx. So that is, it is e log of, if you will put this, so it is log of x, okay, is equal to, so log and e will go, so it will be log of x, okay. So now its solution is y times, now your integrating factor, that's log of x, is equal to integral of, your q of x is 2 log of x, 2, okay. So here 2 by x, isn't, so your q is 2 by x into log of x is integrating factor plus c. So it is y log of x will be here, it is 2 by x. If you will took 1 by x as a t, then take the differentiation, okay. Sorry, log of x as a t, so 1 by x will be its differentiation, so it will be equal to log of x ka whole square, because it will be 2 log of x, so here 2 as a common, so it will be the log of x here. So then 2 as, here you will write m log of n is equal to log n whole raised by m, so that is log of x ka whole square plus c, okay. So this is the solution, or you can make it more clear by this way, that is y is equal to log of x plus c by log of x, and this is the solution for this linear differential equation. Okay, in this they may ask you for the Bernoulli's type, means they will give you the y dash plus y is equal to xy square, or you can write it in this way, dy upon d of x plus y is equal to xy square. So you have seen that on the RHS you have the y square, means y raised to the power n, so you can compare it with the dy upon d of x plus p of x of y is equal to q of x whole raised to the power n. So here n is equal to 2. What will you do? So now your p of x is here 1, your q of x is here x, and your n is equal to 2. So what will you do? You will divide this y raised to the power n throughout, okay. So when you will divide this y raised to the power n throughout, so y square throughout, so that will be 1 by y square dy upon d of x plus 1 by y is equal to x, okay. So now what will you do? You have to put this 1 by y is equal to something. So what will you do? Put 1 by y is equal to some z, okay. So then you will differentiate it on the both sides, so that is dz upon d of x is equal to minus y minus 1 by y square dy upon d of x. So now you have this 1 by y square dy by d of x here, sorry, so that's here, so it will be equal to, so now put it here, okay. So you have now minus dz upon d of x plus z is equal to x, yes or no? So because 1 by y is your z, and this part is here minus 1 by square, so what will you do now? So you have to solve it in this way, so you will get dz upon d of x minus z is equal to minus x, okay. Okay, so here now the next step is that you have now this as a same differential equation, that is of the first, or that's the linear differential equation, so you have to solve it. So you are now p dash is equal to minus 1, your q dash is equal to minus x. What is the integrating factor now? E raised to the power minus 1 dx, so that is e raised to the power minus x. So your solution will be z, because your dependent variable is now z, e raised, so e raised to the power minus x is equal to integral of, here you have the minus x into e raised to the power minus x dx plus c. Okay, so it will be equal to minus x by the parts. Okay, e raised power minus x minus e raised power minus x plus c. So now take this e raised power x, or you can write it in this way, minus x plus 1 e raised power minus x plus c. Okay, so you took the minus common, so you have the z e raised power minus x will be equal to minus x plus 1 e raised power minus x plus c. So what will you do? We will divide this e raised power x minus x on the both sides. So we will get z is equal to minus x plus 1 e raised power minus x, e raised power minus x will go, and plus c e raised power x. So what is our z? You have put the z as 1 by y, so put it will be 1 by y is equal to minus x minus 1 plus c e raised power x is the solution. So आपने देख लिया कि अगर हमारे पास बर्नौलीज डिफरेंशियल इक्वेशन होगी तो हम इस y raised power n को डिवाइड कर रहे हैं और थ्रू आउट, एंड देन पुट इट 1 by y as the z, and it will be converted into the linear differential equation, and we can solve it by the same method, that's the Leibniz linear differential equation. Okay, you can also do the practice to these questions like dy upon d of x plus 4 by x y is equal to x cube y square. And you can, if you will check on the RHS, you have y raised to power n, that's y square. So divide throughout by y square, it will be 1 by y square dy by d of x plus 4 by x into 1 by y is equal to x cube. Now put 1 by y is equal to z and follow the same steps, you will get the answer. Okay, similarly you can practice another one, x dy upon d of x minus 2y is equal to x is equal to 5y cube. First divide by this x, it will be dy upon d of x minus 2 by x y is equal to x is equal to 4y cube. Now divide this y cube throughout, so that is 1 by y cube dy upon d of x minus 2 by x 1 by y square is equal to x is equal to 4. Put 1 by y square is some number z and differentiate on the both sides. You will get this as a linear differential equation. Solve for the z and put the value of z. You will get the solution. And this is the type of the Bernoulli's linear differential equations that may be in your 5 marks question. And if it is the tough, then it may be in the 10 marks question. As I told that another topic that's very important is the exact differential equation. So those equations are in the form of m dx plus n dy is equal to 0, and the necessary condition for the equations that are in the form of m dx and dy is equal to 0 is dou m by dou of x should be equal to dou n by dou of y. If it is equal, then we have the solution. Okay, so then we have the solution in the form of m dx plus integral of n dy is equal to c. In the first term, we are taking as y as constant, and in the second term, we are only in the second here from the n, we are only considering those terms that are free from x. And this exact one is very, very important for your 5 marks question point of view as well as the 10 marks question point of view if the equation will be little difficult. Okay, for example, the question will be is this: solve the differential equation e raised to power y plus 1 cos of x dx plus e raised to power y sine of x dy is equal to 0. Now they will only ask you to solve the differential equation, so you have to see that it is in the form of m dx and this is n dy. So try to solve this by the exact form. So now what is your m here? Your m is e raised to power y plus 1 cos of x, and your n is here e raised to power y sine of x. So now you have to check if it is exact, then it will be very easy. Dou m by dou of x will be equal to that, you have to differentiate this by with respect to the x only. Okay, so when you differentiate this, sorry, it is dou m by dou y is equal to dou n by dou of x. Sorry, it is dou m by dou of y. I am writing it wrongly. It is dou m by dou of y should be equal to dou n by dou of x. Okay, so it is reverse. So it should be dou m by dou of y. So when you will write dou m by dou of y, then you have to differentiate only this e raised power y. So making others as a constant. So it will be e raised power y, differentiation of e raised power y is e raised power y cos of x, and dou n by dou of x. So differentiate with respect to the x. So it will be sine, differentiation is cos, so it will be e raised power y cos of x. So now you can check that dou m by dou of y should be equal to dou n by dou of x. So it implies that our differential equation is exact. Okay, please correct it. This is dou m by dou y should be equal to dou n by dou of x. So then what is the solution? As I told that, then the solution will be integral of m dx plus integral of n dy is equal to c. Here consider as y is constant, and here consider those terms that is free from x. Now what is your m? Your m is e raised power y plus 1 cos of x dx plus what is your n? Your n is e raised power y sine of x dy is equal to c. Now as I told that in the first part we have considered as y is constant, and second we have to consider only those terms that is free from x. So it means here in the term we do not have the free from x, we have the sin x with it, so we will write it as a 0. And here what we have now e raised power y cos of x plus dx plus integral of cos of x dx is equal to c. So now y is constant, so it is power y integral of cos of x dx plus integral of cos of x dx plus c. Okay, so you have to solve this. What will you do? So in this case, what is the integration of cos? That you know, that is the sine, and so you will write it here, it is power y sin x, and that is sin x plus c, sorry, is equal to c. So take the sine common and you will get e raised power y plus 1 is equal to c. Yes or no? So it means that, or this may be the answer, you can write it as well. Otherwise you can take the sign on the RHS, so it will go as a divide. Okay, so it will be e raised power y will be c divided by sin x minus 1. Okay, and even you can write y is equal to log of c divided by sin x minus 1. So you can stop here as well. Okay, so these type of the questions will be in your examination, or the question will be in this way: xy square plus x dx plus y x square plus y dy is equal to 0. So again you can check, this is your m, this part is your n, because m you have dx and n we have dy. So what is our m now? So your m is xy square plus x, and your n is equal to y x square plus y. What is a necessary condition to be exact? Dou m by dou of y should be equal to dou n by dou of x. Let's check what is dou m by dou of y. So you have to differentiate with respect to the y, so you will get 2xy, and the differentiation of this x is as a constant, so it will be 0, and dou n x So here you have the 2xy. So you have dou m by dou of y is equal to dou n by dou of x. So it means it is exact. So what you have? You have the solution as integral of m dx. So that is xy squared plus x dx plus integral of y. So y x square plus y dy is equal to c. But here you have in the m part you have considered y as a constant, and in the x part you have, in the n part you have to only consider those terms that is free from x. So you can check in the first term we have the x, so we will exclude this one, and in the another term we have only the y, so we will include only the y. So what will be here? So take the y square as it is constant, so integral of x dx plus integral of x dx plus integral of y dy is equal to c. So this is y square x square by 2 plus x square by 2 plus y square by 2 is equal to c. So this will be your answer, that is here as x square y square plus x square plus y square is equal to 2c, and you can write it c as. So this is the way how we can write the answer. Okay. Okay, so now if the differential equation is not exact but it is in the form of mdx and dy. For example, ये वाला question अगर होगा x cube plus y cube dx minus xy square dy is equal to 0. Okay, so इसमें m हमारा क्या है? M is equal to x cube plus y cube, and our n is equal to minus xy square. We have to check whether it is exact or not because it is in the form of mdx and dy. So we will check dou m by dou y, and we will check dou n by dou of x. So what is dou m by dou of y? So differentiation of x cube plus y cube with respect to the y. So for this it will be 3y squared. And similarly here dou by dou of x of minus xy squared. So differentiation of x, so it will be minus y squared. And you can check that dou m by dou y is not equal to dou n by dou of x. So it is not exact. Now you have the four rules, whether the homogeneous, whether you will find dou m by dou m by dou of y minus dou n by dou of x divided by n, whether it is a function of x, and similarly all the other three cases. So here you will check. It is easy to see that this is homogeneous, the degree is 3, n is homogeneous, the degree is 3. What will you do? So we will find the integrating factor. That function, if we will multiply to this, it will become the homogeneous. So what is that? In the homogeneous case, so as this is homogeneous, so our integrating factor will be 1 by mx plus ny. So that is 1 by, what is our m? X cube, y cube, and you have to multiply x plus n. N is minus xy squared. You have to multiply y. So you will get 1 by x4 xy cube and xy cube, and you will get 1 by x to the power 4. So now you have to multiply this integrating factor with the given differential equation to make it as exact. What's that? So 1 by x to the power 4. If you will multiply the differential equation that's given by the 1x to the power 4, it will become exact. And for that you will make it 1 m dash dx n dash dy is equal to 0. And what will be your m dash? M dash will be simply you have to multiply integrating factor with that. So that is 1 by x to the power 4 x cube plus y cube. And what will be your n dash? Your n dash will be minus xy squared multiply 1 by x to the power 4. So if you will multiply 1 by x to the power 4, it will be 1 by x plus y cube by x to the power 4, and here it will be minus y squared by x cube. So now it will become the exact by this. So what you will do, you have to check if you will check the dou m by dou of y, so it will be equal to, here it is x is power 4, so it will be 3 y square x raised to the power 4. And if you will check dou n by dou of x, so here it will go minus 3 minus minus, it will become plus, so it will be 3 y square as a constant and x is a power 4, so it will be equal. Now what is the solution? The solution will be integral of m dx, m dash dx plus integral of n dash dy is equal to c. So what is m dash? Here our m dash is 1 by x plus y cube by x is power 4 dx, okay, plus integral of n dash, what is our n dash? Minus y square by x cube dy is equal to c. But you know that we have to consider here only the terms that is free from x, but here we have the x with this term, so that means there is not existing any term that's free from x. So now here what is 1 by x dx plus y is constant, y cube 1 by x is power 4 dx is equal to c. So that is log of x plus y cube, and here it is minus, it will go 1 by 3 x cube, isn't, is equal to c. So you have the solution log of x, so it is y cube already here, so I will write it here, so it is minus, because you took the x is power 4 on the numerator, it will go minus x is power 4, it will be minus, so it is minus 1 by 3, okay, minus 1 by 3 y divided by x whole cube is equal to c is the solution. This is how, when you have the homogeneous, when you have the exact different, when you have to reduce it to the exact differential equation and the given differential equation is exact, okay. Similarly, I just give some of the questions and the tips how you will do it. For example, you have 3y raised to the power 4 plus 3x square y square dx plus x square y minus, or x cube y minus 3xy cube dy is equal to 0. So this part is your m, this part is your n, so you will try to solve this by the exact form. So you have to check dou m by dou of y, so that is 12y cube plus 6 x square y, and dou n by dou of x 3 x square y minus 3 y cube. These two are not equal, it means it is not exact, but you can make it to the exact. Now you will check, now you can check here that this one is homogeneous because the degrees here 2 and 2 is 4, here first term it has the 4, here 3, and here it is 1, so 4, here 1 and 3 it is 4, so it means it is homogeneous. So you will find the integrating factor, that is 1 by mx plus ny, and you will get the integrating factor by 1 by 4 x square y square, okay. So by that differential, by that form, what will you do? So you will multiply the differential equation by this integrating factor, it will become the exact, and you can find the solution, okay. So otherwise you can go through my previous videos, it is written there. Okay, so the another form that you know in the homogeneous is that when your differential equation is in the form of y, any function of x and y, dx plus x, any function of x and y, dy is equal to 0. And for example, this part, as you know, it is your m, and this part is your m, and dou m by dou of y is not equal to dou n by dou of x, then you say that it is not exact. Then you have integrating factor, that means one function that if you will multiply to it, it will become exact, is 1 by mx minus ny. So for that I will give you the question here. So the question I will write y 1 plus xy dx plus x1 minus xy dy is equal to 0. Okay, so try to solve this question, and this part is your m, so your m is here y 1 plus xy, and your n is x1 minus xy. Check dou m by dou of y, dou n by dou of x. Okay, so you will check that it will be 1 plus 2xy, and this will be 1 minus 2xy, so they are not equal. So you have to find the integrating factor, that is 1 by mx minus ny, and solve this, multiply to the given equation, you will get the m dash n dash, and it will become the exact, and you can find the solution. Similarly, try this question as well. I just give you the another question here. Y x square y square plus xy plus 1 dx plus x square y square xy plus 1 dy is equal to 0. Please pause the video for solve this question. It is also of the second case of the exact differential equation, and try to solve it, and find the integrating factor, multiply it to the given differential equation, it will become the exact, and you can find the solution. Okay, so another method, that is the fourth case that's in your syllabus, is when you have the given differential equation. Out of these two cases, another case, if you will find dou m by dou of x, for example this one as a question, if they will give you the 2y dx plus 2x log of x minus xy dy is equal to 0. So what will you do? You will check this one is your m and this one is your n. So dou m by dou y is 2, dou n by dou of x is 2 log of x plus 2x 1 by x minus y. So you will get here as 2 1 plus log of x minus y. You will check that these two are not equal. Even this is not homogeneous as well. So what, it is not of the second case as well. What we will do? We will subtract these two. We have seen that dou m by dou of y is not equal to dou n by dou of x. So it is not the exact, it is not homogeneous, it is not of the form of y times m, y times the function, x times the another function. So we try to subtract it, dou m by dou of y minus dou n by dou of x. If we will subtract it, so you will get here as 2 minus 2, that is 0. So it is 2 minus 2 plus 2 log of x minus y. So you will get 2 log of x minus y. Now what you have, as you have the m as 2y, and n you have the 2x log of x minus xy. So you try to divide it with the n so that it will make a variable function. So dou m by dou y minus dou n by dou of x divided by n. This is 2 log of x minus y, and what is your n? So that is 2x. Okay, so 2x log of x minus xy. Take x common, log of x minus y. Take the x common, so it is 2 log of x minus y. It will go cancel, so what you have? 1 by x. So now what is your integrating factor here? So it is, I think, here as the 2x log of x minus x, and here it is dou m minus dou y, so that is 2 minus, so it will be minus, and this one will be the plus, so it will be plus here. Okay, so this is minus 2 log of x plus y, that is minus 1 by x. Okay, So we have the minus here. So this is your integrating factor. That is the function of x. So integrating factor will be e integral of your function, that's 1 by x dx. What you will get, so that is e raised power minus log of x, so that is e raised power log of x whole raised power minus 1, so that is 1 by x. So now you have to multiply the given differential equation by this integrating factor, that's 1 by x, so you will get the m dash and n dash. So your m dash will be your m, that is 2y multiplied by integrating factor 1 by x, and your n dash will be 2x log of x minus xy 1 by x. So here you have the 2y by x, and here you have the 2 log of x minus y. So now it will become the exact. So the solution will be now directly you can write. So if you will check as well, dou m by dou y will be 2 by x, and dou n by dou of x will be 2 by x. So what is the solution? The solution will be integral of m dash dx integral of n dash dy is equal to c. Here we have the y as constant, and here we have the terms that are free from x. So what is that? In the m dash, 2y as a constant, 1 by x dx, plus n dash, those terms that are free from x, so you can check it here. So we have the log x, so we have to exclude it, so that is minus y dy is equal to c. So now here, so that is 2y log of x minus y square by 2 is equal to c is the solution. Similarly, if you have the question x cube xy cube plus y dx plus 2 x square y square plus x plus y4 dy is equal to 0. You will check that dou m by dou y is not equal to dou n by dou of x. So then you will use dou n minus dou of x minus dou m by dou y divided by m, some function, you will get it 1 by y. So your integrating factor will be 1 by y dy, that is e log of y, so that is y. That will be your integrating factor, and multiply the given differential equation by this, you will get m dash n dash and solve it by the exact. So these 4 cases are there in your syllabus. Okay, so we have seen the Leibniz, Bernoulli's, exact, all the first portion of your unit 3rd. So let's discuss the second portion in the second video. Thank you.